Hello class, good evening, good afternoon, whenever you're watching this. I'm going to make this video on the chemical kinetics lab, lab 4. Many of you requested this video, many of you requested this video today. I do apologize for being a little slow on getting this video out to you. However, I've been very busy this past week, as many of you know. Okay, so let's start with this lab. So you're going to go into your lab cloud. You then are going to click on your announcements. Once there, you're going to click on the chemical equilibrium tab. Here, I give you all the data sets to tell you what data sets you're using. I did make a small typo, and I do apologize for my Friday group, but these last two M's right here, those Mondays, are actually Friday groups. So if you are 315 group A, in my 315 Friday class, you'd be data set 8. If you are 315 on my group B, you're data set 9. We're going to be using all these datas right here. So please click and open all these tabs open, all these documents, along with an Excel sheet, because we're using it a little bit. So let's go look at the actual lab, which I forgot to open. I do apologize about that. Here we go. Okay. So this is the chemical equilibrium lab. For those of you who know from lecture, equilibrium is basically going to make the left side equal to the right side, or make sure they're equal to each other in regards to K. This is using very heavily the Chatter's principle. We'll mention it a little bit in the lab later on. So let's go to part A, procedures. So we're going to set up we're supposed to set up a data acquisition machine using a UV vis scanner again, right? That's why we have absorbance. Retaining 5 test tubes, A, B, C, D, E, and F, which is blank, which is water, which would have been used to calibrate the data acquisition machine. And then in big bold letters here, check to make sure all your flasks and beakers can hold at least 25 milliliters. Because we're told to do this, this is going to be our final volume in a little bit. So what's going on here is that I have 2 solutions. Potassium triocyanate, right there, thiocyanate, sorry, thio, not trio, thiocyanate, and iron nitrate. When these 2 chemicals mix together inside a test tube, it kind of becomes, you gotta get this thing called iron thiocyanate, which is this nice kind of wine looking red color, which is very, very cool. I do kind of miss we didn't do this lab in person, but that lab right there, what's really cool about this is that this chemical is really picked up by the UV vis scanner really well. So that's why we use this chemical. Okay, so here's the set right here. However, since we do this lab on your own, we actually have a data set. Now what's very nice with these data sets is the very first part, all of you guys will get the exact same numbers. Because you look at here, data set A, 12, 2, 8, 6, 4, 2, 12, 2, 8, 6, 4, 0, 2. The only differences between each data set is the absorbance value, which will change things slightly. Now, the only one I did not do for you guys was data set 3. So I'm going to use this as my example. So please do not copy my answers down, because if you get exactly what I get, I know you did not do your own work, and that's why I did this on purpose. I'm making this video to help you guys understand what's going on, but you still need to do your own work. Okay. So the issue with the data sets is it's not the same content. They don't have to put the concentrations up here. The concentrations are 0.012, 0.012. Now, I do apologize for my handwriting. I'm still using a mouse. It's very hard to get my computer fixed when I've been very busy every week. Okay. So M1 V1 is equal to M2 V2. So we're using this dilution calculation because what's going on is we have test tubes, and we're taking 2 chemicals and we're mixing them together. That's going to change the concentration. Now, in this concentration, I only care about iron thiocyanate. I don't care about potassium. I do not care about nitrate at all. And if you do the calculations, one of these numbers becomes very, very big, and one of these numbers becomes very, very small. When dealing with equilibrium, the smaller amount is going to force the reaction to make as much product as possible, because there's so much excess of potassium thiocyanate than there is iron. It's going to force the reaction. So we're going to use the iron cyanate, for example. So I'm going to switch to black. Plug in our original concentration, 0.012. The volume we're going to use is 2 milliliters. We're not going to convert it to liters because they'll cancel out, trust me. Our unknown variable is M2. I'm using lots of colors on purpose because it's been shown in studies you guys respond to colors better. And lastly, our final volume. What is our final volume? If you go read the lab, it mentions that we need a flask or a beaker that can hold at least 25 milliliters of solution. So our last final volume is 25 milliliters. So what we're going to do is divide everything by 25, and that will give us a concentration of roughly 9.6 times 10 to the negative fourth. Okay. You plug that value in as your new concentration. So when solving for something like B, right, you're still going to do M1 V1 is equal to M2 V2. However, your new M1 value will be your 9.6. So it'll be 9.6 times 10 to the negative fourth times V1, which V1 is now going to be your 8 milliliters. So you kind of can cross that out and just put 8 milliliters. M2 is still an unknown. V2 is still going to be 25. You're going to do this you're going to find the M2 for all these concentrations and write it down. Once you've done that, you're going to take all those concentrations, put them in Excel, and we'll compare them to absorbance. Give me 1 second. I'm going to calculate all those things and be right back. Hello, welcome back. Sorry about that. I do some calculations and help do something real quick. Okay, as I left you off, you guys were supposed to be calculating the concentration of solution A at these various volumes. Here's what I got for my data set. Now these numbers for you will look pretty much similar. I ran a little bit differently because I was taught differently in chemistry, and your absorption values are very much different. But here's how you make your graph for Excel. You click, drag, insert. You're gonna do scatter plot. I prefer scatter plot with a line to make sure I'm seeing things correctly, and I am. We are then going to add chart elements. So you're gonna add axis chart elements. You're gonna add a data table data. I'm gonna add a legend, and you're also gonna do a trend line. Good. From the trend line, we're going to more options. We are then going to go down here and type in the equation and R value. Now, I'm not going to show you how to label your graph. You should do it yourself, but it should be calibration curve of iron thiocyanate. This over here should be absorbance, and then here should be concentration. Here is what my graph looks like. Now, your numbers will look a bit differently, but this is pretty close to what you should be getting. So, this is the entire reason why we did the first part of the lab is this guy right here. So this right here is part A. Part A is done. So let's look at how to do part B. Go back to our lab. Part B, determination of Kc. So we're obtaining 4 more test tubes, J, H, I, and G. G, H, I, J, my bad. And we're going to basically add these 2 chemicals together, figure out the concentration, and then that should tell us things. However, since what we did, we have data tables. So we already did that theoretically speaking. And we were given the absorbance values. And since we made a trend graph, we can just take these absorbance values, for example, 0.017, and we can plug that into our graph to get the equilibrium concentration of iron thiocyanate. What I mean by that is what you're going to do is you're going to take your y equals mx plus b formula. So y is equal to, right? But we have our y, so we can actually plug that in. And our y was, so I copied and pasted it, so put it here so I remember, 0.017. 0.171 is equal to 4.25x plus 0.004. You are going to solve for x. You're going to do that. You're going to do that for each exorbitance value. Write that number down. That is going to be the equilibrium concentration for iron thiocyanate. So for this one, I'm going to solve for it. Give me 1 second. 0.171 minus 0.004. And I got a concentration value of 3.8 times 10 to the negative fourth. And that is my concentration of my iron cyanate. Okay. You're gonna do it for all you're gonna do that for every single absorbance value given in your data point, your data table. Here's what and this is the next part you're going to do. So I'm going to delete this. Boom. Next, we're going to do another dilution calculation and the exact same thing. However, this one's a bit different. So remember, we still have these two chemicals and we are adding together. So they are technically being diluted. So for solution G, and I only care about the concentration of my iron. So I have a concentration of 0.012 times 1 milliliter is equal to M2. And my new total volume is both milliliters added up, which is 2 milliliters. So divide everything by 2 milliliters. Cool. You're going to get 0.06. So you're going to get 0.06 for my iron. And you're also going to get 0.06 at the same volume you have the thiocyanate. So SCN. And that is going to make your iron thiocyanate. Now it says make an ice table, and here's what we're going to do. If both values have the exact same thing, 0.06, that's initially. I have nothing here to initially to start. Change end. Well, I just calculated my end. Remember, I got 3.8 times 10 to the negative fourth. And that would be plus x right here. This would be minus x and minus x. So what I'm going to do is take whatever you got for your equilibrium concentration for iron thiocyanate at the absorbance value, subtract that from the ones we just calculated using M1V1. So 0.06 minus my concentration I calculated. And that's got something akin to 0.059. Now that's not the end of the world. It's pretty good, 0.059. Not very high, but it will change over time, trust me. So boom, 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 that's going on there. You're then going to do Kc value, and your Kc is your products over reactants. Plugging those in, so I have 3.8 times 10 to the negative fourth over 0.059 times 0.059. So, give me 1 second to calculate this. And I got a Kc value of 0.11. Now, some of your Kc values will be very high, some will be very low. These are these are actual students' data from the semester, which we did not have COVID. So some of these numbers will be very good, some of these are very bad. This Kc value is pretty low compared to everyone else's, so don't worry if yours is super high. Whatever you get, just report it. As long as I can see you guys' work and your math, which you should be showing me, I will give you points or partial credit if even your numbers are really crazy. You're gonna be doing that for all of them. I'm going to show you to do H real quick because H is a bit different. But if you know how to do H, you can do I. Again, we're going to do iron first. So 0.012 times 2 milliliters is equal to M2 V2, which in this case is 2 plus 1, which is 3 milliliters. So all that stuff divided by 3 milliliters, and bada bing, bada boom. You get 0.08. Right? 0.008. I messed up my previous calculations. I do apologize. That is why my number is off. I'm off by a factor of 10. So let's see if I can undo a lot of things. I do apologize. This should be 0.06. 0.06. Sorry, my dyslexia kicked in. Let me fix that in real quick. My dyscalculia and dyslexia are a problem. I do apologize. So let's do that real quick. 0.006 minus the number we calculated. There's 0.0056. 0.056. So I do apologize for that. I did catch my mistake. We all make mistakes. I do apologize. Yeah, but change by a factor of 10, but change by a factor. Instead of being 0.0, it's actually going to be in that big purple color. It's going to be 11.88. I'm fine if you want to round that to the next whole number, which would have been 12. I'm fine with that. You're going to do the exact same thing for all of them using the same calculations. Here's a summary sheet. Do not worry too much about section A. Fill it in the best you can. That's my bad. My mouse freaked out for a second. Fill it the best you can. Don't worry too much about that section. Worry more about everything else. So give the concentration and the absorbance. The wavelength used is going to be roughly 490. 490 nanometers. Okay. You're going to insert your graph here at part C. You're going to show me all the work of the data table. Fill it in. The equilibrium is what you find in the graph. Initially is what you calculate using the volume and the concentration. And then once you figure the initials out, you subtract the equilibrium and you get it here. We then are going to get a Kc value of all of them, plug the numbers in, add them all up, divide by the number you have, and you should get there. If your Kc value is negative, put Na instead, do not report it. That says it right here, Kc cannot be negative. So if you do get a negative one, please do not report it. Post-lab questions, answer these to the best of your ability. Most of you are very smart people, and I know you can. The only ones I'm going to explain are ones related to the lab. 4 and 5, you guys can do on your own. 1 should be pretty obvious, the constant, if they're going to be all the same or not. So, if the values are not equal, is there dependence on the values of Kc and the initial concentration of this? Is there a dependence on this? It's up to you. I would say yes or no. You need to tell me. The answer is no. Why? You need to tell me why. Explain why the concentration of Ks is so much larger. That is because it's so much larger, we want to force the reaction all the way. Now, most reactions, unlike strong acids, strong bases, do not dissociate 100%. So with a very, very large potassium thiocyanate, we can force the reaction to completion, and that's what we did. Okay, that is the lab. Hopefully it was helpful. If you still have questions, please let me know. I can't do much more than that because I can't do the lab for you guys. That is how you go into the lab. I understand a lot of questions. If this was not helpful, I can help you guys out independently. Okay. Thank you for coming. Have a good day. I will see you in class.